Hello, this is Professor Francis. I'm going to help out with questions 15 and 16. There's a lot of math on those questions, and I've been getting a lot of emails asking for help with those questions. So I thought I'd post a video so everyone can get the help at the same time. We're going to start with the first question on question 15, which really has three parts. The first part, starting up here, the basis of this question is, for both formulas, calculate the volume of formula that would meet the energy needs of a patient who requires about 1,750 calories daily. Use the results to answer the following questions. And we'll get to these two parts of the question next, but for now, let's just do this first part of the question. What is the volume of formula that we need? Okay, so you're going to use Appendix G in the back of your book. If you look in Appendix G, look up the formulas. I believe we're using Gevity and NutriHep. You should find those in Appendix G and look at the information for each nutrient in there: calories, protein, carbohydrate, and fat. The first thing that we're going to look at is how many calories per milliliter does the formula deliver? I'm going to use an example that has 1 calorie per milliliter. I think I'm using, I can't remember the name of it, but in any case, I'm using a 1 calorie per milliliter formula. Please note that when you are doing your homework, that Gevity has 1.06 calories per milliliter and NutriHep has 1.5 calories per milliliter. So as I'm going through this example, you're going to be using different numbers, and I'll tell you, we're going to start with just the Gevity, and we'll go through and I'll say remember to use your numbers for Gevity. Okay? So for my formula, which is 1 calorie per milliliter, I would take the calories, which are required by the patient, 1,750, and divide by the 1 calorie per milliliter. You would divide by 1.06 calories per milliliter right here. My answer comes out to be 1,750 milliliters required to deliver 1,750 calories. Makes sense, 1 calorie per milliliter. You're going to get a number that's less than this. Okay, so as a check, note that your answer should end up with a number of milliliters that is smaller than the number of kcals, because the number of kcals is more than 1 per milliliter. So your answer should be a smaller number of milliliters than calories. Okay, so now that you have your volume of formula, I have 1,750, you're going to have a smaller number since you're using these numbers for Gevity. We can start to see what nutrients are delivered in that volume of formula. Okay, so again, you're going to look at the table in Appendix G. When I look up Nutren is the formula that I'm using. When I look up Nutren 1, I see that there are 40 grams of protein delivered in 1 liter of formula. And I'm getting that right from the table. I'm not calculating that. I'm looking at the table when it says in 1 liter, or the table might say 1,000 milliliters, same thing, 1 liter. How much protein is delivered? For the product that I'm using, it's 40. For the products you're using, Gevity and NutriHep, there's a different amount. Okay, so look that up right now and jot it down. Once you know how much protein is delivered in 1 liter of the formula, you need to figure out how much protein is in the amount of formula that you're going to deliver. So in my example, I'm going to use 1,750 milliliters. 1,750 milliliters is 1.75 liters. Okay, so I'm going to multiply my 40 grams of protein times 1.75 liters to get a total of 70 grams of protein. Okay, so in your example, whoops, I'm sorry. Oh, we have to go. I'm sorry. So in your example, you're going to have a different amount of protein because you're using a different formula, and a different volume because you had different calculation on the first page. But you're going to multiply the grams of protein times the volume that you're delivering. Similarly, you're going to do the same thing with carbohydrate and fat. Okay? You look up the grams of carbohydrate per liter and multiply it times how many liters you're giving. Look up the grams of fat delivered in 1 liter and multiply it times the number of liters that you're giving. This will give you how many grams of carbohydrate and how many grams of fat you are delivering. To find the total calories, remember that protein and carb have 4 calories per gram and fat has 9 calories per gram. So we had 70 grams of protein in my example times 4 calories per gram. That means 280 calories from protein are being delivered to this patient. 224 grams of carbohydrate times 4, 896 calories. I'm sorry, this should say carbohydrate right here. It should say carbohydrate. 66.5 grams of fat times 9 calories per gram is equal to 599 kcals from fat. Total calories is the calories from the protein, calories from the carbohydrate, and calories from the fat, all added up. You should notice that they're going to equal very similar to the amount of calories that was your goal. So my goal was 1750 calories. Because of rounding and just various errors in formula making, it's not going to come out to be exactly 1750, but it should be very close. If you're getting a number that's like 1900, 2000, something like that, then you've done something wrong. Go back and check. Okay, so our total calories was 1775. Now, if you'll remember, the original question was, what percent of calories are going to come from protein? What percent of calories are going to come from carbohydrate? What percent of calories are going to come from fat? So what we're doing is we're looking at the calories from protein compared to the total, the calories from carbohydrate compared to the total, the calories from fat compared to the total. I've done those calculations on the next page. Okay, the calories from protein divided by the total equals 16% of the calories come from protein. The calories from carbohydrate divided by the total equals 50% of the calories from are coming from carbohydrate. With the fat, 599 calories from fat divided by the total calories equals 34% of the calories from fat. Now, if you go back to chapter 1 and look up on page 10, the acceptable macronutrient distribution ranges, you'll see that the AMDR for protein is between 10 and 35%. The AMDR for carbohydrate is 45 to 65%. The AMDR for fat is 20 to 35%. All of these fall within those ranges. What I want you to bear in mind, however, is that these acceptable macronutrient distribution ranges are the DRIs, and the DRIs apply to normal or the average healthy individual. And you should realize that people who are receiving tube feedings may not fall into that category. Your patient who's receiving a tube feeding may not be your average healthy patient. So some of these formulas are designed to meet the specialized nutrition needs of patients, and so that it makes sense that their percent of calories from protein, carbohydrate, and fat may be higher or lower than the acceptable macronutrient distribution range. For example, a particularly high protein formula might be for certain patients are going to have a percent of calories that are greater than the AMDR for protein, and it's specifically designed that way. So in your NutriHep question, that is a very specialized formula. So when you get to the end of that problem, after you've gone through all these calculations, if you find that the AMDRs, the calculations don't fall within the AMDRs, don't think that you've made a mistake, because it's probably designed specifically to meet the specialized nutrition needs of those particular patients. Okay, so that is the first part of question 15. I'm going to do a different video for the second part of question 15. So we'll see you then.